In this example, we have y equal to the natural log of 20 minus 23x squared raised to the fifth power times 5x plus 10. And so what we're going to do is we're going to use some of the properties of natural logs or logarithms in general in order to simplify it and then take the derivative. So we're going to get the natural log of 20 minus 23x squared to the fifth plus the natural log of 5x plus 10, because the rule says that when you have a log of a product, it's equal to the sum of the two logs. So here's the first factor in our product, 20 minus 23x squared, quantity to the fifth, and here's the second factor in our product, 5x plus 10. So now I've taken the log of each factor and then added them together. Then there's another rule that says that if you have the logarithm of an expression raised to a power, that power, in this case, 5, will come down. So I'll go ahead and take that 5, and I'll draw a little arrow down. And so then that gives us the following. It's equal to 5 times the natural log of 20 minus 23x squared plus the natural log of 5x plus 10. So now that I've simplified y, what I'm going to do now is go, hey, look, now let's take the derivative, because it's so much easier to take the derivative of this expression. So y prime is equal to 5 over the argument, in this case 20 minus 23x squared, times the derivative of 20 minus 23x squared, which is minus 46x. And then we're going to take the the derivative of the second term, and it's going to give us 1 over the argument, 5x plus 10. And then in the numerator, we have the derivative of 5x plus 10. And the derivative of 5x plus 10 is 5. And so we have that y prime is equal to 5 times 46. 5 times 6 is 30. So I think it's minus 230, but I'll have to check that. Over 20 minus 23x squared. And then 5 happens to go into the both terms in the denominator. So we have 1 over x plus 2. Because I divided the 5x by 5 to get 1x, the 10 by 5 to get 2, and the 5 by 5 to get 1. So that would be an easier way to find the derivative.